Hi everyone, and welcome to the Sampling from Populations lecture. In this video, we're going to talk about what it takes to achieve a good sample. If we don't have the money or the personnel to conduct a census survey of an entire population, and that's most research studies, we rely on sampling strategies. Sampling is when we take a subsection of the population we want to study and we analyze the sample's characteristics. We then use the sample characteristics to estimate the population characteristics. Say, for example, we have this population we're trying to study, and we want to know the average age of everyone in the population. We don't have the money or the personnel to talk to everyone in the yellow circle, so we decide to pull a sample of 100 people out of the larger population. The full population that we are studying is the yellow circle. The orange circle is the subsection of that group, our 100-person sample. Once we gather all 100 people, we can run statistics on their ages to figure out the average age of our sample. From there, we can estimate the average age of the entire population. Now, in order to make sure that our population estimates are as true as possible, we have to be careful about the size and the composition of our orange circle. It's important to consider the differences and similarities between the yellow population circle and the orange sample circle because it helps us identify and reduce sampling bias. Sampling bias occurs when the sample does not look like the population for whatever reason. This could be because the sample had to voluntarily participate and people who volunteered are somehow different than those who didn't. Think about it this way. If I called you at noon on a Tuesday and I asked you to participate in a 1-hour-long phone survey, would you do it? Do you have an hour to spend on the phone call at Tuesday at noon? Probably not. In fact, most people in school, stay-at-home parents, and working adults won't be able to say yes and volunteer for the study at that time because it's a busy time of day. So who would be likely to say yes? Well, older adults who don't have children in the house, retired adults, and people who are unemployed or disabled. They might be more likely to say yes. Voluntary participation may not be the only reason that your sample doesn't look like the population. A good sample is one that captures the diversity of the population. And if you're using a very small or a homogeneous sample, then you're not capturing that broad diversity and you will probably make biased estimates. So we want to think carefully about who the sample is comprised of and who they are trying to represent. To reduce sampling bias, we want to make sure we have a representative sample. A representative sample means the sample looks like the population in terms of important characteristics. Let's say you're attempting to sample from this population and you get a sample that looks like this. Doesn't seem like a very good sample, huh? When the sample does not represent the population in question, it creates sampling bias. The goal of sampling is to estimate something in the population based on the characteristics of the sample. But if your estimate is biased because your sample doesn't represent your population, then it creates biased estimates as well. On the other hand, if you achieve a sample like this, you can feel much better about your estimates. A representative sample, meaning a sample that looks like the population, is generalizable. Generalizability refers to our ability to make conclusions about the population using the estimates from the sample. If we have a sample that is generalizable, it means we can accurately estimate the population characteristics using the sample. A non-generalizable sample is one that creates biased population estimates. When we have a representative sample that allows us to generalize their characteristics to the full population, then our study has what we call high external validity. Studies that have sampling bias from small or unrepresentative samples will have low external validity. Here's an example of the importance of representativeness. Let's say I'm interested in finding out the favorite literary genre of college students, and I go to a Star Trek convention to gather my sample. My sample says their favorite genre is science fiction. Can I then conclude that all college students prefer science fiction books over others? Would you believe me? Hopefully you said no, you wouldn't. What's the problem with my research? Well, you guessed it, the representativeness of my sample. The population that I'm trying to generalize to is all college students, but I'm gathering people from a Star Trek convention only. That means my sample is heavily biased towards those individuals who would attend a Star Trek convention, meaning they probably enjoy science fiction novels to begin with. This sample doesn't represent the diverse opinions of college students, and therefore any conclusions I make based on that sample will be biased. So how do we achieve a representative sample? There's 3 ways. First, a larger sample, and that makes sense, right? The more people you include in your research, the more likely you will capture all of the diversity within your sample. Statistically, the best way you can achieve a representative sample is to take multiple samplings. So instead of just sampling 1 time, you sample 100 times. Then you use statistics to average out the scores of each sample until you can generate a strong estimate of the population statistic. In theory, excellent, but in practice, rarely used. You might as well just do a census study if you're going to have to take 100 different samples. Finally, the last method is to use random selection. This means that when you're sampling, you're collecting participants from the populations fully at random, with no design or intention behind your selection process. In another lecture, you're going to learn the most common sampling methods that use random selection. Regardless of which method you use to study your population, one important decision that you need to make during your research design is to determine who or what you will actually be studying and analyzing during your research. This is known as the unit of analysis. Unit of analyses can be anything. They can be individual people, they can be countries, they can be books, television shows, airplane rosters, anything. One of the more common unit of analysis used in criminal justice research is the individual. Individual research means that you're looking at a human being, and you're looking at each human being's specific actions, behaviors, thoughts, feelings, perceptions, whatever. If your data is at the individual level, then you can distinguish how Susie feels about criminal sentencing compared to how Stuart feels about criminal sentencing, compared to how Rajesh feels about criminal sentencing. You gather information from each specific person. Groups are another common unit of analysis. A group is a collection of human beings that are organized together in some manner. Groups can be as simple as a household of 3 family members or as complicated as police agencies with 30,000 employees. If you're gathering data at the group level, then you cannot parcel the data down to a specific person's information. So we don't know how Rajesh feels, but we know that people at the university Rajesh works for feel a certain way. Because of the lack of individual level data, group data often comes in the form of percentages or rates. Now, sometimes you don't necessarily want to study a group of people so much as a specific location or geographic area. That can also be a unit of analysis. In the image here, the unit analysis is census blocks with a measurement of population analyzed for each census block tract. Now, here is something that you need to keep a lookout for when you're critiquing research findings. The important thing about the unit of analysis is that you should always make conclusions at the same level of analysis as the data you collect. If you don't, you'll commit what's known as a logical fallacy, meaning that you'll be making conclusions that aren't accurate. Now, research methods has its own language, so we don't just call them logical fallacies and be done with it. There are 2 types of fallacies that relate to the unit of analysis issue. The ecological fallacy occurs when you gather data at the group or geographic region, and then you make conclusions about the individual level of analysis. For example, let's say I'm studying how crime rates are impacted by the unemployment rate within a city. I collect data at the city level, so my unit analysis is a geographic region. My data looks like this: Chicago, 10% unemployment, Detroit, 11% unemployment, so on. When I analyze my data, I find that cities with higher unemployment levels also have higher crime rates. When I write up my reports, I describe how these findings show that Joe, an unemployed man, is at higher risk to commit crime than Bethany, an employed female. What's the problem? The ecological fallacy. What I've done is I've taken geographic data and then individualized my findings to a specific person. My research only shows that if Joe lives in a city with a higher level of unemployment, then his city will have a higher crime rate. Any conclusion that tries to infer something about Joe himself is at the individual level analysis, and I don't have the data to support that conclusion. As you can guess, the individualist fallacy works the opposite way. If I gather information at the individual level, then I cannot make conclusions about the behaviors of groups. This type of fallacy is what drives bias, as we will observe behaviors of individual people and then ascribe those characteristics to all people of the same age, gender, race, religion, etc. So one woman who doesn't pay attention while driving doesn't mean that all women are bad drivers, right? That conclusion is based on the individualist fallacy. Okay, that concludes our lecture video on sampling from populations. Thanks for watching, everyone.